This time we look at how a group of airmen flew the aged and poorly armed Catalina on night raids against the Japanese shipping. Their only real protection was the black skies of the night and the black paint of the aircraft. These squadrons were called Black Cats. In this episode we check out two aircraft of the Lockheed Company. Both these planes were designed by the famous Kelly Johnson. Kelly's list of achievements is stunning, such as having input in over 40 of the world's most renowned aircraft, and over half these were his original design. This time we focus on his F-104 Starfighter, and the most famous of all, the Blackbird. The Catalina was used extensively during World War II, but there was one very special Catalina squadron that should be recognised for their daring and ability to keep the old planes flying. The Catalina's age is evident in the laborious task of preparing a Catalina for a mission. More modern aircraft had better and quicker methods of flight preparation. The Catalina was a hands-on job. In the Pacific region, isolated squadrons relied on mechanics to recycle parts, manufacture parts, and above all, be creative to keep the planes airborne. With the most basic tools, the mechanics were able to keep this simple machine in the air. Bullet holes were fixed with tin snips and a rivet gun. In the Pacific, the Catalinas flew secret missions and were painted black. They became known as the Black Cats. They carried bombs, depth charges and torpedoes. They only had a couple of 50 caliber machine guns for defence, and this was no match for the gunnery of the Japanese fighters that they often encountered. They most often worked alone, and the only cover they had was the black paint that helped camouflage them in the night sky. The Black Cat crews left at dusk, and their flights extended well into the night. At that time, there wasn't any such thing as global positioning, and night flying gave them little opportunity to navigate by visual means. Their main means of navigation were the stars. The crews mostly flew blind. Although nearly invisible to the eye, the engine noise often alerted the enemy to the presence of the Black Cats, and if they were lucky, the Cats would be able to get first strike and withdraw in success before the enemy could get into full swing. The old Catalina was very susceptible, and its age was a real barrier to any performance flying. However, with black paint and the ability to skim the ocean, it provided a cat and mouse game of detection. There are very few Black Cats left in the world, and the Historical Aircraft Restoration Society has restored this example. The aircraft was purchased in 2002 in Portugal, where it had been operated as a water bomber under Chilean registration, and was flown to Australia in September 2003. The aircraft is a PBY-6A model, which is very similar to the more common PBY-5. It is an amphibious model, where the Black Cats were seaplanes. The choice of amphibian was made when purchasing the aircraft on the basis of convenience, as its role to this day is to visit as many air shows as possible so that people can view this remarkable plane. Today people are educated on the role of the aircraft and the airmen of the Royal Australian Air Force who gallantly flew them under cover of darkness from remote Pacific locations. In all, 239 Australian pilots lost their lives flying top secret and near suicide missions to keep the Pacific Ocean open. In all, the RAAF had a total of 166 Catalina aircraft. As this aircraft was left in storage for 20 years, a team from the Historical Aircraft Restoration Society flew to Portugal to get the craft to airworthy condition. After much work, the plane was ready for the long haul to Australia. One of the final stages of the preparation was the testing of the plane's engines, and this was achieved by running the aircraft up and down the runway. Once satisfied with the plane's mechanical and airframe condition, it was flown for the first time in over 20 years. Flight plans were then made to bring the Catalina to its new Australian home. Its first stop was to be England. However, a devastating hydraulic fluid leak occurred and the PBY was forced to land in France. The crew ran checks and got the main landing gear down. But the front gear didn't respond. It had to be manually lowered. The next problem to be overcome, the plane had lost its brakes. To compound the problem, the provincial airfield had a very short runway. The landing did not go well. The main portside landing gear failed, and the PBY's hopes of reaching Australia on schedule were dashed. This heartbreaking event is typical of the hurdles that face any organisation that embarks on restoring such relics. Fortunately, the Catalina was not extensively damaged, and the Historical Aircraft Restoration Society returned at a later date and repaired the PBY. The rest of the story is history, as today this magnificent example of restoration is now fulfilling its role of proudly flying before the crowds as both a tribute to the aircraft and those brave aviators of the Black Cat squadrons. This is the story of the F-104. This time we look at one of the many legendary planes designed by one of the world's most awarded aviation designers, Kelly Johnson. We'll be following the path of the much maligned but equally inspiring F-104 Lockheed Starfighter. From Kelly's initial concepts in 1952, through the painstaking development, and then the wonder what could have been after the last 104 was produced in 1983, a production run that lasted over 30 years. Kelly Johnson first came to the Lockheed Company in 1933 and was hired as only the sixth engineer of the fledgling company. He had come to the notice of company engineers when he was supervising the wind tunnel testing of the company's Electra at the University of Michigan. His insights and constructive concepts on the Electra and subsequently the Hudson bomber led to his rapid rise in the company. The Hudson bomber Kelly single-handedly designed at the age of 29 was then redesigned to meet the British specifications in a number of days in his hotel room to seal the Lockheed order, which eventually ran to 3,500 planes. Kelly's list of achievements is stunning, such as having input in over 40 of the world's most renowned aircraft, and over half of these were his original design. The American pilots flying their Sabres, who were used to their air superiority, were being increasingly pushed in the air war by the MiG-15s. Kelly Johnson, on his visit to Korea, was left in no doubt about the requirements for the next step forward. The American pilots he'd spoken to were demanding a plane with vastly better speed, height and climb parameters. With the need to be higher, faster and to be there quicker, Kelly's decision was for a lightweight fighter designed for high subsonic cruise and high supersonic combat speeds. Almost immediately, the most controversial point of the 104's design was decided upon: its incomparably small, thin wing. This flew in the face of design thinking of the time, which was for larger swept wings on all transonic planes. The next point of the wing controversy was that the wings were to be bolted onto the sides of the fuselage with precision forged aluminium fittings, not going through the plane, as with most planes of the day. As the Air Force had not asked for submissions for the 104, and if it were not for the credibility of Lockheed and Kelly Johnson and the lessons being learnt in Korea, the 104 may never have gone into production. As it was, they were impressed and perceived a need enough to order prototype testing on an experimental contract. In March 1953, the contract was issued, and Lockheed went straight into production of the first two prototypes. The first flight took place only 12 months after the signature of the contract. The achievements in that 12 months are stunning. Its concept had only been developed in late 1952 and was not some idea that had been sitting on a file for an extended period. It was on the cutting edge of technology for the time. On March the 5th, 1954, the 104 made its first official test flight. After an extensive testing sequence of the flight controls, the test pilot, Tony Levere, took to the air for the first time. Although the engine used in the test aircraft couldn't push the plane past Mach 2, Lockheed's design and concepts of the lightweight interceptor were decisively proven. In spite of the prototype's tests not achieving the airframe's Mach 2 speed, the US Air Force placed an order for 15 more planes with uprated power plants as F-104As. In April of 1955, one of these broke the Mach 2 barrier. With the long development period and the plane's extreme performance being very unforgiving on an unwary pilot, a test flight sequence of over 8,000 flights using 52 aircraft still left a guarded attitude with the Air Force, and Lockheed were left with the inference that the plane was still on trial. The contracts issued were the first to be on a fix then fly basis. Previously, the Air Force would assume some of the testing itself. With the cutting-edge technology of the 104, the responsibility was returned to the manufacturer. This is now the accepted practice. When it first appeared in the mid-1950s, it had a futuristic look about it, and its small wing area and needle nose earned it the nickname of Missile with a Man in it. The F-104 was the first operational interceptor capable of sustained speeds above Mach 2, and was the first aircraft ever to hold the world speed and altitude records simultaneously. Although a successful plane and very revolutionary, many pilots had trouble with the F-104. Some dubbed it the Widowmaker due to the high rate of pilot fatalities. Major General Fred J. Ascari described the Starfighter as scary and fast. He went on to say, and I quote, "If you want to get an idea of how dangerous that plane is, you should dig into the German Air Force accident records for the 104 and count the fatalities. They attribute them to pilot error, but it wasn't the case. I think they lost something like 85 F-104s in the first 1.5 years of flying them. 85. That's more than 2 killed a week during some weeks." They blamed it on the pilot, but the plane had a nasty tendency to pitch up under certain conditions, and there wasn't much you could do to save yourself under those conditions. It wasn't and still isn't a very forgiving plane. It will not forgive a pilot the slightest error, and you will get into fatally hot water fast. Unquote. In 1958 and 1959, it set new records in many fields to reinforce its potency. Even when the new F-4 Phantom II broke some of its records, The 104 went out and reset them again outside the F4's capabilities. The 104 was later redesigned with larger wings and much more manoeuvrability as the Lancer, which entered as a concept in the competition that brought the F-15 to mass production. It would seem that the Lancer, for some reason in the thinking of the time, failed to impress, and none were ever put into production. Kelly Johnson maintained that the Lancer would have run rings around the F-15 and thereby everything else at the time. There is even a body of opinion that says in aerial combat, the 104 itself would give the F-15 significant problems. Although the last of the Starfighters were built in 1983, these exceptional aircraft served for many years, but were finally withdrawn from service in the mid-1990s. The only variant still surviving is the F-104S, built under license by Alenia in Italy for use in Italy and Turkey. Despite the age of the F-104, the S model has proven to be cost-effective, reliable and popular among pilots, giving the F-104 a new lease of life into the new century. We continue with the design concepts of the Lockheed Company and Kelly Johnson. Many of the designs set the company and the man so far apart from their contemporaries at the time that to this day, in one design alone, that gap has still not been breached. These planes were so secret, it is only with the benefit of time we can now look back in awe of their achievements. Even then, we will probably never know all they were capable of. To build a plane that would achieve a cruise speed beyond Mach 3 and an altitude of 80,000 feet, totally new design concepts needed to be developed. It would also require totally new materials to be developed. Along with this was the requirement of engineering new tools and machines to make new aircraft parts. Everything about this concept would have to start from scratch. During 1957, the 12th proposal presented to the government met with approval, and so development began on Oxcart and the A-12. The planes of this series were later to be known as Blackbirds. Lockheed had in the past used titanium in some of its developments. However, this venture would require 93% of the plane to be a new titanium alloy to achieve the integrity required. Even to this day, the landing gear is one of the largest titanium blocks ever forged. At Mach 3, the outside skin of the plane would be between 800 and 1100 degrees Fahrenheit, while the outside air temperature would be 120 below. The stresses on the airframe would be more than anything ever attempted before. Every aspect of this plane's development was new or exhaustively adapted. Even the basic fact that standard construction tools would corrode the titanium alloy had to be overcome. Because of their cadmium coating, which caused its corrosion, these tools had to be reforged to suit the production process. Totally new presses, mills and lathes had to be developed for use with the new alloy. Presses would now have to function at over 1500 degrees Fahrenheit. New non-corrosive cutting fluids would have to be developed. The list was never ending. What is probably most amazing in today's world is that all of this was achieved without any computers. It was all done with slide rules, pencils and pieces of paper. Every individual piece of the plane was tested, even the wheels, tyres and brakes. With what this plane was expected to experience, nothing could be left to chance. The A-12 was first displayed to the public on the 30th of September 1964 as the YF-12A Interceptor. The airframe was in its simplest form, a blended body and delta wing, built around two of the largest engines ever built for an aircraft. The Pratt & Whitney J58 engines produce 160,000 horsepower and the inlet temperatures can reach an incredible 1100 degrees Celsius. The long flattened fuselage, thin wings and specially designed paint achieved the first in genuine stealth technologies. In fact, the Blackbirds had less than 1% of the radar signature of a B-52. On the ground, the Blackbirds actually seep fuel from their fuel cells, but once in flight, the expansion from high Mach temperatures soon seal all of these small leaks. Kelly Johnson asserted that each flight above Mach 3 would in effect re-temper the titanium alloy of the plane, in theory, prolonging the airframe's life indefinitely. The main difference between the YF-12A and subsequent models was the shortening of the chines along the sides of the nose. The SR-71's existence, SR standing for Strategic Reconnaissance, was first announced by President Johnson on July 24, 1964, and the first flight of an SR-71 took place on December 22, 1964. Officially, only 32 Blackbirds were ever built. However, because of the secrecy surrounding the planes, it is safer to say at least 32 were built. In 1968, a presidential order required that all moulds and tools used to build the SR-71 be destroyed, so that the plane could never be built by anyone again. This also meant that spare parts could not be made, so if there were any major problems, planes in storage would have to be cannibalized. Though the Blackbirds have officially been withdrawn from service, their cruising speed of over Mach 3 and a service ceiling of over 26 kilometres has ensured that many of the records they established still stand today. In all the years of the Blackbird program, no SR-71 was ever shot down or hit by enemy fire, and they were known to have outrun over 4,000 missiles. However, they did suffer many losses. In fact, up to 20 were lost, mostly on the ground during landings and takeoffs. In 1990, with a reputed price tag of over $30,000 per hour, the SR-71 program became too expensive to operate, and their last flight took place on March the 6th, a blistering California to Washington in 68 minutes, fittingly another record.